Oh yeah, look at this bad boy, sex on a stick. This is the new NGP800 series, just released in late February, and thank you very much, Rohde and Schwarz, for sending this one in. It was just unannounced, unrequested, but they figured that I didn't have enough good power supplies here in the lab. You've seen the previous ones. I clearly don't have enough quality power supplies here, so obviously they sent me their brand spanking new one, because these were the HMP one. Given that they've got H in front of them, of course, they're the older HAMEG design ones, and of course the one up the top is the newer, that's the NGE, but this bad boy down here is the new Rohde and Schwarz NGP800. In particular, this is the NGP814. So this is like the top of the line 4-channel model. You can actually get a 2-channel model, apparently, and it simply just has these unpopulated. No, you can't put anything else up here, because that's actually the vents, as we'll see, to get the air in. And look, whoa, it must be all touchy-feely, because it's, you just select the channels here and the back and an output on-off button, and that's it. Whereas the other ones, they actually took some getting used to. They're great once you actually get used to sort of like the user interface on the things. But yeah, this one should be significantly easier in terms of usability, I suspect, even though I haven't powered it up yet. Ooh, what's a star button? Turns you into an electronic superstar. So you might think, oh, well, why have they done this one instead of what's wrong with this one up here? Well, not only is it an older design, but they still sell it. All these are still current models and they're still excellent, but this bad boy is twice the output voltage. That you can get a 64 volt option and twice the current as well. It can go up to 20 amps. And also twice the power. It's got 800 watts total, whereas this one up here only had, their previous top of the range one only had 360, something like this. So this is designed for, serious lab and production, test rack integration and things like that. This is a really serious bad boy power supply, 800 watts, all independent channels, all remote sensing. It's got all the bells and whistles about remote comms and everything else. So, let's check it out. So basically, yep, it's touchy-feely user interface, twice the voltage, twice the current, twice the power capability. Oh, let's go. This is literally their top shelf unit. And as I mentioned, we've got the front vents here to suck the air in over the power supply modules, as we'll see. No vents on the side, but over on this side, we do have some vents, but that's basically for like a transformer ventilation, so to speak. The actual power supply modules, there'll be 2 of them in here like this, I suspect, and so it gets the majority of the airflow coming from the front here. And of course, if you've got this thing shoved inside a rack, that's where you want the air coming from. Look at those badass terminals on the back here, all 4 channels there, or like output and remote sense as well for all 4 channels. Wow, they're absolutely enormous. 2 big fans on the back, and what's a Kensington lock there, because, if you got this in a university lab or something, you don't want the students nicking it. IEEE 4008's not populated, bummer. And of course, multiple digital triggers, and it looks like analog signals as well, which you could possibly trigger off or sample or do whatever. Because one of the key features of this is apparently it has login on like all the channels. I don't know the sample rate, don't know the bit rate, bit depth, and all that sort of stuff. But anyway, we got USBs and LANsies as well. I think there might be a wireless option. Well, you know what we say here on the EEVblog, don't turn it on, take it apart. Except not with this, because that's a Philips, and it looks like these aren't Philips. Oh! Of course, they got thread sealers on it. One good thing about power supplies is that you can never have too many of them. Golden rule of electronics. Made in Malaysia instead of Germany. Geez, what are they trying to do? Outcompete Keysight? Keysight get all their best stuff made in Malaysia too. Ooh, it's not void. It's expired. Ta-da! Percussive maintenance required. Oh, I can just smell the quality from here. Oh, this is fantastic. Oh, wow. Oh, look at this bad boy. Wow, well, I don't know where to start in this thing. Isn't this gorgeous? The first thing I noticed when I took it off is that there's an Ethernet cable running from the main board at the back here through to the front panel. That's interesting. So they've got PCB mount Ethernet cables on there. Wow. Notice all the big cables coming across here, cable ties on there to hold those in place. Oh, they're silicon as well. Oh, wow. Oh, they're beautiful. Oh, this is not field of vision, but yep, you can just tell none of that PVC rubbish there. Fantastic. Of course, that's for the rear panel output connectors and sense lines as well. The smaller cables in there are the sense lines, obviously, and they've got to come from the front. Might have to actually uncable tie everything to get this board out. Anyway, I was completely wrong about the layout. I just assumed that there would be a board here going the whole length like that to be like 2 channels and another 2 channels here. The mains power supply is up the back here. This is interesting in its own right. We'll take a look at it. And then there's 2 square boards here. That's 2 channels. So you can see the heatsinks there. So these 2 channels are the factory channels, and then these 2 on its own board over here, identical board of course, is the other 2 channels. And yes, all 4, even though it is a separate board for each 2 channels, all the channels are actually completely isolated in their own right. So I don't immediately see how the power comes into those. It might be via little standoffs. So let's just have a look at the mains input side of things here. Very nice ferrite there, like that. It's all properly heat shrunk. The mains power supply is not a separate module. They've integrated it onto this main board here. These are the main input fuses. Look at this. They've actually fused the active and the neutral as well. Absolutely fantastic. And then we've got, of course, our input filtering. We've got a big MOV in there. We've got our filtering to ground, of course, so X and Y class caps. And then we've got common mode choke, of course, more extra filtering on the other side. And oh, it looks like there's another common mode choke in there, really buggering off. Is it power factor corrected? Power supply? I don't know. Anyway, they say this is like a really efficient power supply. Tiny little fan controller down there, 2 cables, so that actually controls both fans, so that'll bugger off over there. But look, this is like integrated onto the main board. It really is quite remarkable, because in most designs you want to separate your mains power supply from the rest of your board. You want to either get another external company to design the power supply and manufacture it, then you just bolt it in, and that's easier and cheaper and all sorts of stuff. But they've integrated absolutely everything onto this board, so it's fantastic. So you can see that they've got ground earth running around the outside here. There's not a huge amount of clearance in there, but I guess it's adequate. What is that? 5-6 millimeters, something like that, between mains and earth in terms of creepage distance. Anyway, our mains earth looks like it's down there, and they put that in a gorgeous big slot with the cable underneath there. So that's really remarkable. So yeah, you can see the earth cable buggering off there under that fan, and then it actually goes into there. So that's really belt and braces. Very impressed by that. Oh, that Ethernet cable there, literally an Ethernet extension cable. So there's the Ethernet connector down the bottom there, and that just connects it up through to the main board over here, and that's all our processor stuff is on the front there, on the front panel. And curiously, we have a whole bunch of power supply stuff integrated down into the main board here. Look at these big current shunt resistors there. Wow, they're huge. Like, we've got a little controller in there. Can't see the part number, but obviously, and with the choke and the diode and the cap and other caps around there, that's obviously, a switch mode. We've got a whole bunch of those, which is rather interesting, and they go up via this blue cable. All of that is a regulator for all of the circuitry on the front panel, all the processor stuff by the looks of it. So why you wouldn't have that over on the actual processor board? I don't know. Did they run out of space? It's a really interesting decision. Maybe these are all your different rails. These are, your 3.3, your 1.8, your 1.2, or your core voltages for your various whiz-bang processors that you need these days. Which is very interesting that you separate those right on the other side of the product. I'd say they just probably didn't have room on the front panel and they thought, oh, you know, look, we've got our power supply people laying out this anyway, they may as well do all this, you know, the power supply group or something. And then that goes over here to this seriously interesting looking custom switch mode. Obviously the power's coming from over here, you can see it jumping through all the vias here. It goes all the way up here, always follow the money, then it goes through a fuse into there like that. So it's a multi-phase flyback, is it? Anyway, current shunt resistor over there. There's an opto. And of course, it just dawned on me, these would be the 4 separate isolated supplies for our 4 channels, as in for the control stuff, not the actual power. It's just for the control circuitry. So, I see it now. Based on the layout, these share a common ground here. You can see there, and there. So that is 1 channel, 2 channels, 3 channels, and 4 channels. That makes sense because we have a 4-channel power supply, 4-channel isolated converter, like relatively low power. I would presume the control logic on each individual channel. Well, this is interesting. I'm having a hard time getting this out here, but the upper 2 channels here, which is the optional channel 3 and 4 here, is on its own little PCB. So some of those big beefy red and black cables go into there, but the other one is actually integrated down on the main PCB down here. Yes, that's integrated down there with the mains power supply. It's all just really fascinating and probably essential system design, because they're trying to squeeze like a 4 independent channel 800 watt power supply into a 2 rack unit high thing here, and well, yeah, they just have to do a lot of unusual design measures to get all this sort of stuff to fit. Now, I really would like to show you the mains power supply, but unfortunately I can't because it's under here. And they've got thermal adhesive between the 2 heat sinks either side here, because this adds really not a huge amount of actual thermal performance. But what they're doing there is basically using that as like an air guide to force it under and through the fins, just so that there's, like, you know, less airflow over the top, I guess, or less turbulent flow or whatever. That just one flat part. If you wanted to increase the thermal performance, you would have added like fins on top of here and, you know, going in this direction, of course. So you'd have your various drive transistors on these 2 heatsinks and or diodes. There's a big ass choke under there on its own little single-sided PCB down in there, but that's all I can see, really. Sorry, unless I get a better angle later on. And here you go. Here's how they're getting the power to the boards over here. Dead giveaway. 2 large pins here in this surface mount connector, bottom board entry, so they got holes in the bottom of the board. They just come through up into that. So that's how they're getting the input power over to each channel. So there's one there and there's another hiding behind the ribbon there, and then they've just got some like miscellaneous power as well. Love to be able to show you the brand of the caps under there. Unfortunately, nope, we're not getting that out. Hang on, I see a bodge. We got one!
We got one!
There it is down there, check it out. Little mod wire, gunk down, very nice. And is that a little ceramic cap under some silicon gunk there? Looks like it. Last minute jobby, and they obviously didn't want to respin the board. Maybe in the next production batch. And of course, if you had your thinking cap on, you would have realised, Dave, how do we get our isolation on all 4 channels? Don't we need an isolated, like, supply, like an isolated transformer tap, or however it, you know, old school transformer taps and full wave bridge rectifiers. Come on. Anyway, don't we need our isolated input like this? Well, of course, obviously, they haven't done that here, right? There's no way that they can get 4 independent isolated channels here. So I betcha, bottom dollar, if we measure the inputs of between 2 different channels, we'll find that they are shorted. And yep, it's not isolated on the input, it's isolated in the converter itself. So yeah, that's what these bad boys are doing. That's how we're getting our isolation on the output. It's not done at the input side of things. So all of your stuff down on that logic level connector down in there, that'd all be common as well, I'd guess. And yes, the output ground also with a large high voltage ceramic jobby going down to mains earth as well. Once again, that's for suppression. So I undid all those cable ties there and I was able to slide out that plate. Luckily I didn't. I could slide it out and don't have to undo these because I'd have to unbolt every single connection if I wanted to get those out. Anyway, good news is all 4 channels absolutely identical, so we only need to look at one. All right, let's have a squiz at this bad boy. This is one individual channel. As I said, they'd all be identical, and yes, they are all isolated, as I said, so you can stack the channels in series or parallel to your heart's content. Anyway, as I said, we've got the input coming out. I almost certainly this is the input here. So underneath that's actually not a resistor, that's actually a heat shrinked PCB fuse there with soldered end caps, so all individually fused, of course. We've got ourselves a large ceramic cap going down to mains earth here, so that's for suppression, of course, and then you've got miscellaneous control and voltage stuff coming in here. Now this is interesting. Let me see if I can get a close-up on that. Now what we're actually looking at here is a current transformer. Check this out. We've got all these fine windings, of course, going around the ferrite, but then through it we have this winding here which goes through that. So it's basically a current transformer, a current clamp transformer. Now in this particular case, because of its physical location here, it seems to be measuring the input current to the actual converter itself. So probably for like overload protection or monitoring, something like that, perhaps, because it's obviously not measuring the output current because you can't do that in this physical location on the circuit. So yeah, that's neat. But curiously, if you go to the other side of these chokes here, by the looks of it, we've got another couple up there as well. So once again, this is doesn't seem to be measuring the actual output current. So I don't know why they need to do that twice. Bueller. And that choke's an absolute beast. Look at that. Oh, wow, what is that, 2 mil solid copper? Oh, it's about 1.7 mil. And all of the devices on this heatsink, including this here, which is actually going to be a thermocouple, they're all just stuck down. None of that screw rubbish. They're stuck down with a thermal adhesive tape there on all the heat sinks on each module. There's 3 heat sinks total. Oh, we might be able to get a part number down there. There's all the rest of the parts going on there. Is that a pick? Are all the pick fanboys going to go wild? Without being able to see those numbers, I'd be guessing we probably have like a DAC. We're going to have an ADC in there. And we've got ourselves a real fair dinkum relay as well. Got some miscellaneous regulators. And those 4 babies down in there had a good look, and they're STTH2002s, ultra-fast diodes. And check out this bad boy on the heatsink here. Oh, isn't that a Bobby Dazzler? Yes, that is a 5 milliohm current sense resistor. It's a 4-terminal job, of course. 2 for sense and 2 for the actual resistor itself. And yes, it is thermally mounted onto the heatsink there. I don't know what the part next to it is, though. But anyway, that is obviously where they are measuring the output current from, and that would be worth a pretty penny, that thing. Down on their own heatsink down there are 4 60R360s. That'd be MOSFETs. Now this is actually starting to look an awful lot like a resonant mode controller. It just makes sense. Well, it's a basic generic resonant mode topology, but I think we're going to see that line up here. We've got ourselves our 4 diodes down here. We've got ourselves 4 MOSFETs under here, so I think that's what we're going to see. So that's probably just part of an output filter, I'd say, but yeah, I'd say, yeah, it's coming in here. This is our full wave bridge. These are our caps. Stick with me. And we've got an inductor, we've got a then our isolation transformer, we've got our 4 output rectifier diodes down here, and then there's, as I said, there's another MOSFET under here, so I'm not quite sure what they're doing there, and then we've just got some output filter in. So yeah, I think that's how it works. Sure, the power supply aficionados will all be commenting down below about what's going on here, but anyway, it looks to be some variation of a resonant mode controller. Exactly how they're doing it, I don't know. We'd have to reverse engineer it, and that would require ripping the whole guts out. So rather curiously, all of the wires here are actually soldered down to the PCB down here. They're like crimped into little, you know, proper little crimping lugs, and they're there soldered down to the boards. So all that wire in there, yeah, you can see the ground wire down in there. There you go. Focus, you bastard. There you go. Right down there. You can see that they've got those crimp leads on there which go into the board. So nice attention to detail there. But yeah, that's surprising that they didn't use an off-board connector. So check out these output boards down in here. Look at the huge big crimp terminals here, absolutely massive. And so we've got shake-proof washers, the whole shebang. So that is very nice. All your terminals. Once again, I think they got a little, maybe a little bit of output capacitance there. Not much, of course. In a good lab power supply, you do not want too much output capacitance, because then when you transition from constant voltage to constant current mode, you got all that energy in those output caps, and you don't want that to dump into your poor little load that you're trying to instantly protect. So yeah, you can't just whack, you know, 10,000 mic on the output of your power supply to make it super stable, and then yeah, not think you're going to come a gutser when you power your circuit. Nah. Eagle-eyed viewers will have no doubt spotted the ceramic on the output there. I think that could be, once again, some suppression to ground, I think. I don't think that's directly across the output, no. Because I've done a video on where ceramic caps like that can explode, and if they get cracked, micro-cracked, they can short out, and the magic smokers can be released. And you've got I've done a real interesting video on that, actually, a couple of videos, and how you can solve that by using either put 2 in series, or you can solve that by using specially constructed ceramics that fail open or are simply more resistant to cracking due to various construction techniques. Anyway, there is our, there you go. It looks like it has integrated, factory integrated Wi-Fi. I don't know if that is like a software option or not. Who knows? Anyway, sorry, it's hard to really get down into this board, so please excuse the crudity of the video. Didn't have time to build it to scale or to paint it. That looks like a free scale jobby down there. There you go. So that's the applications process that's driving all the touch screen woo-woo. And yeah, you got all the requisite memory, flash, and DRAM as well. Nice headers down there. There's 2 headers. Are they JTAG headers? That'd be really nice. I spy a reset button, or it could be like a serial interface UART as well. So yeah, it'd be interesting to probe those. I won't do that in this video though. But anyway, that's just your requisite control board. Nothing special, really. But anyway, those output connectors, whoa, Bobby Dazzler. So as you can see, the construction in this thing, absolutely gorgeous. First class design and build quality, worth every cent, and you're paying for it. I mean, this is the top shelf Rohde and Schwarz power supply just released. So yeah, hats off to the design team. Very, very nice indeed. Just whacking this back together, and noted the little RF fingers there. Nice. Alright, let's power this bad boy on. Unfortunately, soft power button on the front. Does have a real clunking power switch on the back though. So, hopefully I reconnected everything. Let's go. NGP814 power supply. Beauty, because there is no model number on here. It's just NGP800. So, they don't actually bother to tell you that. Rohde and Schwarz, boot in. Boot in. Oh, what? What was that? Okay, that was just like soft booting. Is this... Hello? Oh, there we go. Okay. Yep, now we're doing the real booting, are we? I suspect. So it was just booting up to standby mode, effectively. I suspect that's what was happening there. So, yeah, not exactly the world's quickest booting power supply, so everyday use, but this is not for everyday use bench power supply. So, yeah, sit back, twiddle your thumbs. Oh, boy. Yeah. Oh, there we go. We're in like Flynn. Look at that. 4 separate indicators for the 4 channels. Absolutely fantastic. I love that. Hang on. That's yellow, but that's orange. Okay. Okay, I've got my color balanced studio lights on here, and well, yeah, yellow, and that's supposed to be orange. Wah, 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 wah. Yeah, I can kind of see it, but it's just not the same. They really should have picked another color. I don't know about like the whole colorblind thing and things like that, so I'm sure our colorblind viewers will tell us all about that, whether or not they're suitable. But yeah, no, I think that's a poor choice. But anyway, it doesn't really matter because it's obvious that's channel 1 and that's channel 1. They're physically the same. So yeah, no wuckers. Press our output button on. That's it. We're just going to start measuring. Oh, 1 milliamp there. So obviously, without reading the manual, there you go, channel 1. So we've got, okay, so there you go, output 1, off and on. So these are your enable buttons for your channels, and this is your complete on-off output. So that absolutely makes sense by default. It comes as 1 volt. That's about 3 millivolts under, but you know, nothing doing there. Can't use our knobby knob for anything, really. That's just a selection thing. Oh, by the way, yeah, for those complaining at home, there we go. Let's peel that bad boy off. There we go. So let's press the home button. I guess the home button, we are in the home menu. I mean, we can call up, yeah, there's all our menus. We'll check that out later. This won't be a review. Sorry, it was more of a like unboxing teardown thing. But presumably, can we just touch that? Ah, yep. Hope the knob works. Oh, yeah, the knob sort of didn't work. Yeah, it goes up in increments, so obviously our cursor's in that position. But the problem is, like, you can't just like move your cursor over and like select, like there's no arrow keys on here to move your cursor over to set the jumping increments. It's 1 volt. So that's the very first thing I noticed about that. Anyway, I do like the display. It's really good. And I'm sure it will change color, like to red or something, if we go into constant current mode from green to red. But anyway, we've got our set voltage and our readback voltage, our set current and our readback current for each channel. So it's nice. It's got output power as well. Brilliant. So yeah, I like the interface. It's nice, except, yeah, how do we, like, yeah, I can hit that. Okay, and then I can, like, oh, okay, there we go. So then I can use that to sort of, let's go 10 millivolt increments, shall we? And then we're, yeah, okay. It's there, but anyway, it's going live too. That's the other thing. It's outputting live, so it doesn't wait until you, like, push the button. Oh, no, there we go. There we go. I figured it out. Oh, that's pretty nice. Okay, yep, that's really good. Okay, no, I take back what I said about that. That's really good. I can then go to there, just move the cursor by pressing that. Ah, very nice. Yep, thumbs up. And sure enough, yep, if you whack a load on it, go into constant current mode, there it is there. It's dropped from 6 volts to 1.1, and of course the reason it doesn't match here is 1.1 out here, and it's 1 volt reading on here is because of the drop in our leads and our connections, because we're not remote sensing anything. I really like that even though it's displaying only 1 milliamp there, you can actually set down here in increments of 0.5 milliamps. So you get a little bit extra for your dollars there. Now, of course, this is an 800 watt power supply, so that means it's limited to 200 watts per channel. So there'll be a voltage current envelope there. So you can't just go to the maximum 0 to 32 volts, 0 to 20 amps. You can't just go, oh, I'll take 30 volts at 20 amps, please, because you're going to blow your 200 watt budget here. So if we go to channel 1, for example, and we set it to 30 volts, we can't just go into here and set 10 amps here, 10 amps on our current there. No, sorry, we can only go to 6.666. And there's nothing unusual about that at all. Any well-spec'd lab power supply will have a power envelope like that, it's called, and you'll actually find that in the manual. And no, I can't get it to hiccup or do anything like that with our BK Precision Power Supply Killer here in constant resistance mode. It's just handling that just fine. No workers. Anyway, 20 amps output capability, that is very nice. That, not too many lab power supplies will go up to 20 amps, so that's absolutely brilliant. And as for the noise in this thing, I can barely hear it. The fans are actually going, but they're obviously temperature, I assume they're temperature controlled because it's pretty silent. And if I switch the load off, can still hear them going. But geez, yeah, it's quite a low level background. I'm in a whisper quiet lab at the moment, and yeah, you can hear it, but certainly not annoying. All right, let's go and explore some of our options, shall we? Let's go into the channel. Look at this, output. Let's go into delay. We can set a delay on our channel. On, I assume we set that up somewhere else. Remote sense, of course. Auto, that's very nice. So we can set it to external sense here if you've got it hooked up. But yeah, auto is nice. If you plug it in, it's going to detect that. I don't think the others had that. Oh, I don't think so. Please correct me if I'm wrong. And yep, hi, the screen is a bit reflective, a little bit annoying, but it's par for the course these days. Anyway, overcurrent protection, I assume that's just software overcurrent protection and over voltage protection. Of course, absolutely essential if you're powering, like I've powered up boards worth, like 50 grand. And it's like if you blow them up, it's like the first prototype, or it could be worth $1 million, because if you blow up that one prototype board and you lose your schedule for your project, and $1 million or $10 million projects hanging by the thread of, literally by the thread of these wires powering up the prototype, you don't want to blow the arse out of it and release the magic smoke. So that's why you do over voltage protection, to make sure if it's a 5-volt board, for example, you'd set your over voltage protection to 5.25 or 5.5. So just to ensure that you don't go over that limit, and over current protection as well. That is different to your output voltage and current settings. It just means that some idiot manager can't come along, or marketing person can't come along and start twiddling the knobs and playing with the panel and actually blow up your $1 million prototype. And it's got ramps as well enabled. Can enable our ramp. Our ramp time, that's just nice. Like, I could put it on the scope, but I guarantee you it's going to work. It's just going to ramp up over the 1 second. Nice linear ramp. Absolutely fantastic, because some supplies, especially on real complex semiconductors these days, you've got to bring them up in the right sequence and in the right amount of time. So, they're really handy. And then you've got arbitrary stuff, and I'm sure you could, PC software. I could literally spend a week and a several-hour video actually fully reviewing everything on this power supply. So obviously that's not possible. Over power protection as well, very nice. Analog input, so we can tie our analog input to, once again, I haven't read the manual for this, so analog, voltage or current, set. So what do? I guess we set that somewhere else, so analog enabled, so it won't, so we can switch on or off based on an analog input, perhaps. Adjustment, user restore factory adjustment, user adjustment if you want to self-calibrate, I guess. And safety limits. What are safety limits? There you go. Once again, what's the difference between safety limits and over voltage, over current protection? But geez, well, they're taking this seriously, aren't they? This is absolutely incredible, and you've got all this for each individual channel. So let's go into device. So in our arbitrary waveform editor, can we actually draw? Because we do have a touchscreen, can we like draw in like a dick and balls or something and then have it generate that? That'd be cool. But anyway, I'm sure you can tie that into other Rohde and Schwarz gear like scopes, so you can capture a waveform and then maybe replay it on your power supply, something like that. Tracking, of course, if you want to track up multiple channels, if you want to adjust once and then have any or all track, can you set individual? Yep, look at that. You can set, I want channel 3 to track channel 1. Thank you very much. Fantastic. Digital I/O trigger, so there you go. So yep, you can set that to trigger. I'm not sure if you can assign those to individual channels. That'd be kind of cool. And then we've got all our interface stuff. We've got our networking, of course. We've got our Ethernets and our Wi-Fi's and our USB classes and all that sort of goodness. User-defined. Oh, that's a user-defined button. We figured out what the star does. There you go, user button action. What does it do? Oh, screenshot. Oh, that's fantastic. Or you can turn on login. Absolutely brilliant. So let's just reset statistics. Oh, touch lock. If you want to bugger off the touch screen, if you don't, as I said, you know, if marketing or management's coming around to like have a look at your latest prototype, you want to like turn off the touch screen so the dickheads can't screw it up on you. That's great. I like that, but I'm going to select login. Thank you very much. So if we actually go out of here and we switch our outputs actually on, and can we just hit login? Oh, there we go. It's a little tiny log icon up there. So it's logging that, log in all 4 channels presumably, and I presume we can export that to CSV to our heart's content. So absolutely terrific. I like the menu interface. It's very simple. You've got like the entire device, one like this, or individual channels, update device, licenses and stuff like that. CSV settings, there it is. Yep, so that's for your login stuff. You can change what format you want. Geez, they really went to town on this. That's absolutely terrific. I'm impressed. This is good. And we can go full screen. Oh, look at this. Look at this. Wow, there's all our stats as well. So that's where we could assign that button there, reset our statistics. Oh, absolutely terrific. So if we turn on channel 1 here, there we go. We're actually logging and we've got stats and we can reset those. Tells us how many, I presume that's, yep, there we go. We can just reset that there. Oh, energy as well. It does energy calculation. Look, watt hours, there it is. In this case, milliwatt hours. Oh, great for battery testing and stuff like that. This user interface is fantastic. I'm really liking this. This is going to be my main bench supply. This one's a Bobby Dazzler. So there you have it. I might leave it at that because, as I said, a full-on review could take forever. But if you do want to see something specific, you can actually leave it in the comments and I might be able to shoot like a quick video and whack it on the second channel. That's what my second channel is for, really, is just whacking like, really quick take, quick and dirty, single take, quick and dirty videos over there and stuff like that. No spit and polish, no nothing. But anyway, this is absolutely fantastic. New NGP800. I don't know the price. If you have to ask the price, maybe you can't afford it. But it is an absolute Bobby Dazzler. Thank you very much, Rohde and Schwarz. Wow, this is top shelf stuff. I'm impressed. The user interface is they've really thought about that and works well as like other Rohde and Schwarz gear works, like the Rohde and Schwarz scope that I got. It works absolutely fantastically from like a user interface point of view. Lots of spit and polish has gone into the design and functionality of this thing, and yeah, they just released it. I'll try and maybe whack in some prices or something like that. I don't know what the equivalent competitors are from other manufacturers, but yeah, this has got winner written all over it. Absolutely fantastic, but it's not for your low-cost lab. Like, none of this sort of Rohde and Schwarz gear is really. It's not built down to a price. It's built for performance and functionality, and you know, you certainly pay a bit of a premium for that, but wow, it's worth every cent. Fantastic, love it. Anyway, if you like that video, please give it a big thumbs up. As always, you can discuss down below and over on the EEVblog forum, and yep, you guessed it, my library channel. Oh, it's getting up there. I'm number 5 in the world. I'm hoping to pass Veritasium. That's my next target, I think. Yep, so I think Derek from Veritasium is going to come a gutsa soon, and the EEVblog audience are going to surpass him. So check that out. Linked in down below, as always. Catch you next time.